So what we were doing before was we were iterating over the image, just sort of saying, okay, if we have a 16 by 16, it divides up evenly into 2 by 2 tiles, right? So we get our 4 sprites. And what we said is we don't want to do that by default, because for something like, or not even by default, we don't want to do that as our only way of handling this, and that's because with something like the ship, we want to have this one, and then this one, and then like this one, or something to that effect. It's not to scale because I can't draw an actual square there. Something like that, right? That's what we want for the ship. But there are going to be other sprites where we do want just that sort of even 8 by 8 division. So what we have to do is, by default, assume that that's what we want, and then we can go back and tweak the JSON file. So, two parts to this. If the number of tiles is 0, if new sprite number of tiles equals 0, then we want to calculate the number of tiles just based on the width and height. So new sprite number of tiles, and this would be for an example if we bring in a new sprite that we never had before, and we want to import it and generate the JSON file, and then have that as the starter point where we go in and modify how we're selecting out the sprites from that larger image. So number of tiles is image width times image. Well, actually, what is it? So it's image width divided by 3. Divided by 8. That gives us our tiles wide times image height multiplied by 3, and that gives us our full number of tiles. And then for I is equal to number of, well, we got to do two things here. So new sprite let's do this. Tile positions equals malloc size of vector 2b times new sprite number of tiles. And we've got to make an exception for this if the thing is animated. Although I don't know that we would even know that at this point. Maybe we forego that in favor of keeping this simple. I don't know. We'll see. My goal for tonight is if we can get this exported and working in the NES side, I will be happy. Number of tiles. Alright, so we've got that. We've got that mem set. And then we're going to just iterate over the dimensions of the image. And generate our tile positions, right? And for our tile position index, tile positions TP index equals x equals x, and y equals y, and we're just iterating through the dimensions there, and then incrementing to the next one. I think that should take care of that. So let's see, if we take something like the player, and we just do that, and then we say we want to export that to shooter assets png player test.json. Let's see, as NES asset tool, not asset tool. Oh, it's sprite to JSON. That's what it is. Let's see what that actually looks like, assuming it didn't crash and burn. Didn't seem to like that. Unless it's, let's say, sprite to JSON. No, it gets the target name, it just didn't work. Alright, so let's see why that didn't work. Player.sprite. That didn't get overwritten. Why? There's player.sprite. Okay. I don't know why it's keeping the old date even though I deleted that file. And then I ran it and came back. But okay, fine. I saw a problem with something similar like that before, with the Windows acting weird. So what's the problem with this now? Target file name. Load sprite. Okay, and then the JSON output file, target file name. Oh. It is ignoring the second argument, or not ignoring it, potentially just not using it. I thought I was telling it what. No? Okay, I guess not. I thought for some reason it was using. Okay. Collision points. That's fine. I was just misremembering. So now we need to generate the here. Sublime Text is going to help me out here. It's called sprite position. Okay, so we're going to generate the sprite position so we've got an array of our objects, and we're going to iterate through that. We've got our number of tiles, and we're just going to do the same sort of thing we're doing here, which is we're going to do our sprintf and generate our x and our y, and p doesn't matter right now because we're not even dealing with the position, the palette, and then tile positions ix, current sprite, tile positions iy, and then we're going to just write this out. We need the same kind of thing here to check the current situation of if we're going to write a comma or not. So if I doesn't equal, or I plus 1 doesn't equal the number of tiles, then write a comma, otherwise we're done. Okay, so what we should see is not what we're seeing. Why are we not getting a number of tiles? Oh, maybe because, let's re-export this. Need the comma there. Oh, not there. Oh. Did I not include the close? I didn't. Okay. That's a minor thing to fix, but important nonetheless. Okay. So now it's valid JSON, but we are dealing with the fact that the sprite position is not getting loaded. So the reason the sprite position might not be getting loaded is because we may have a bug in our, well, a couple of things. Most likely it's a bug in the export or the PNG conversion process. So let's start there with our default default export behavior that we just wrote. Alright, so we are going into here, so that's good. So number of tiles is 4, that's good too. We're allocating tile positions. We're setting it to 0. And then TP index is equal to 0. And then we're going for image width and height. Oh. Okay, so this is definitely wrong. This should be plus equals 8. And that should be plus equals 8. And let me see, it's already written the sprite at this point, so that's part of the issue as well. All right, let's try that again. So that should be better. Yeah, that looks better. So now that that's exported, if we run this to get our JSON file, we should see wrong file. It updated new sprite to have the number of tiles, and then we have a number of tiles, and the tile position should be set. Image width, that all looks right now. Let's take a look at that. Zero zero 0888. That's correct for a 2x2. And our tile positions buffer is set there. And new sprite has init number of tiles is 4. Alright, that all looks good. And then not initially. Oh, why does it think there's... Oh. I forgot that the prior command was loading the JSON file. This isn't even the right PNG file. Alright. There we go. Alright, so now it's hard coding it to just use the basic positions there, and then we can say I just want to load the sprite file, and that's the original ship, and that loads correctly. So what we can do now is we can try and export that. That'll be interesting to see with the original drawing. A little scared to see what this does. Let's see here. Assets shooter assets map1.text. Let's see what that actually ends up doing here. Draw entities. Is this the... Where's this one from? This is not the exported one, so let's take a look at that. Export. Draw entities. Okay, so that actually looks reasonable so far. The sprite is... player sprite is that. That looks okay. That all looked okay. That seems... could not... okay. Well, that would do it. It didn't actually try to export it this time. So what is it? Map 1. Oh, that's why it's shooter.text. All right, let's see how badly this fails. We can actually... let's delete that and re-export. Abort. Export map. Load sprite. Collision points. Oh, right. Okay, so we've got to, let's do a couple things here. Right, this is because the image data has been changed, so now we've got to go through the process of exporting everything. So PNG to sprite. So let's look at all of our sprites here. So we have flyby dot C projects shooter assets. PNG flyby.png flyby2.png explode.png what else? We have explode. We need the bullet, the player, the flyby, and the flyby2. So bullet.png. Okay. So let's take a look at these here. So that, for example, looks fine. Now flyby.png. Oh, .sprite. That looks fine. Although actually I didn't check the background color. Let me check this again. I think that, I don't know which one is. Okay, so that's that, and then that can stay there. Save that. So bullet flyby, flyby2, player. Now through the player, we have that weird problem with the collision points being wrong. But let's do this. Let's export the player now. We get our JSON file. And again, this is the, obviously this is with the old sprite, but I'm just testing that these changes didn't break the old format. So X is, let's just say 4, and Y is 0. We just want the one collision point, and then we're going to do PNG to sprite for player.png. And use the JSON file as our starting point. And then for explode, we need to look at that one. We want to make that animated. We're going to save, close. Let's reopen that. Okay, that looks good. We just want to swap the colors now. Like that. Save. Okay, that looks good. And now let's try and export the map again. Alright, so that didn't crash this time. Now that the sprites are presumably in the right format. And let's take a look at draw entities. So explode, bullet, player, flyby, flyby 2. So let's take a look at... Alright, so we know animated is not working properly. I'll fix that. I figured that was going to be the case, but that's okay. Draw player. Draw player sprite is now looking good. Okay, so let's fix the animation stuff here, because it's really terribly broken. So anim%d. All right, so the number of tiles for an animated sprite is not just number of tiles. Let me think about this for a second. So if we load that up, well, it's going to be we're going to say if current sprite is animated. Oh wait, no, I don't want to do it like that way. Current sprite is animated. I mean, that's what I was thinking in my head, but that's not what I wanted. Then what we want to do is what we were doing before for the total sprites, where we were saying we want to use the sprites animated size. So what does that actually translate to? I guess it's what it was before. Let me, rather than recalculate that, let me just take a look at what that line looks like. Total sprites. If it's animated, it's the width divided by or times the height. Oh yeah. Yep. Right, it's the frame width times the frame height, all divided by 64. Tell us how many tiles we have. Okay, so let's re-export that, and now that should be a lot shorter. Let's see, 0, 8. Okay, so the problem now is that because it's animated, the position of X and Y are getting modified or getting adjusted by this. So let's do this. If current sprite is animated, if it's not animated, then we don't want to do this. Or sorry, if it's not animated, we want to do this. If it is animated, we don't, because we want to just calculate it simply based on position within the, yeah, that looks good. And then we go to draw player, and that is going to use what's in the tile position stuff, and that's good. That all looks pretty good. So let's see if now we put it into the game if that works. So Let's replace all the files and build. No reference to unnamed label. That's fine. All right. So shooter.nes. Where are you? Let's see how this goes. Should be interesting. All right, so that's actually not terrible, or not as bad as I thought it was going to be. There are a couple of problems. One is we did not re-export well, the meta tiles shouldn't matter. So I'm not sure why. I'm not sure why that got broken. Let's see if those other sprites are okay. They are. So that's fine. It doesn't appear that the collision point got registered. All right, let's take a look at that. Let's see, first of all, did we bumper dot meta tile? Okay. PNG2 meta tile. PNG. Weird. I don't know why that changed, but okay. So we gotta re-export those. I mean, obviously it's due to something that got changed with the format of the things, but blue.png, or what is it? Is it blue tile? Sorry, blue tile. Green tile. And gradient. And then we re-export the map. And then we grab our assets again. And I assume that that's going to fix it because it looks like it was consistent with what we were loading in the asset tool, which is cool because that means that it should get fixed now just by, no? I feel like it didn't actually fix. Let's clear this all out. Blue tile, green tile. Okay. So let's pull this over. I just deleted everything and re-exported just to make sure that it actually changed. I actually don't even know if I, come to think of it, if I rebuilt the code. So it's entirely possible that I didn't. And then I restarted messing, thinking that it would do something, which of course it won't. Oh, good. Now that's totally broken. Okay, well at least that's showing up. And that collision still works. So, oh, you know what? This might be a palette issue. I'm wondering if it's a palette problem. It does appear to be potentially, yeah, these palettes are wrong. Let me fix that. I hadn't thought about that. The bumper was fine, but let's I don't know why. Yeah, so that's what that was. So this is the blue tile, right? And then toggle that one, save it. Okay, so that was easy enough. That was just a simple mistake with the way that meta tiles were exported, because I didn't deal with the palettes properly, which is still something that's kind of nagging with all of this stuff, that the palettes are still not properly handled. Where is Messin? I guess I closed it. Okay. Relaunch the ROM. And let's make sure this looks good now. Blue tile is still wrong. I think it's because it's not called blue.metatile, it's called bluetile.metatile. And that's why that was wrong. And let's export that and do it again. Build it again. Alright. I think this should get it. I mean, the map is now loading properly. There we go. That was really the issue with all of that. We got our sprite loading correctly. We got our collisions working properly. So now what we're going to do is I'm going to try to use the new functionality we built. That's weird. Why was Sublime Text sitting like that? We're going to try to use the new functionality to swap out to the new ship. So we're going to call this player.png. We're going to call this old player.png. And then we're going to call newship.png player.png. And we're going to export that. And then, actually, what we want to do here now is we want to change this to 4.0, and then that. And that should be it. That should actually just now work. We should be able to take that. Let's see. It helps if you use the right file name. So that worked. And so far as, yeah, so let's save that. And then let's export this. Let's see what our draw entity looks like now for draw player sprite. 400888. Awesome, and it's only got the 3 tiles. That actually looks right. So we should now see the new ship drawn properly as generated by the asset tool, which is pretty exciting. There's a folder. Okay. So, here we go. Not exactly. Really close. Like I see part of it. Let's take a look at the PPU and see what the deal is. It's got this tile. Oh, it's okay. So it's got, interesting, it's got it's got part of it, but it's wrong. Let's go back and look at that again. I wonder if there's some code that's assuming the offsets here based on the prior calculations. Because what I'm seeing is, what am I seeing? Okay, so the drawing is actually right. The sprite itself is incorrectly exported. The CHR, the char data, is wrong. And that's fine. I actually didn't think about that too much. So I expect that that's probably just using the old routine for exporting the char data there, which needs to be fixed. So let's do that. And I gotta look here, but what is it? Is it entities.char? There's entities inc, entity_char.char. Okay, so it's just exporting inc bin sprite. Okay, here it is. This is what needs to be fixed. Aha, yes, okay. Okay, so we can do what we were doing sort of before, and we can change this to take... where else do I use this? I'm thinking I might use this for the meta tiles too. No, you can't find it. Thanks. Meta tile to image. Okay, so what I'm going to do is I'm going to change this to export sprite char. Or I'm going to create a new one called export sprite char. It's going to work a little bit differently. I'm going to call this export sprite char. It's going to take a file name. It's going to take the vector2b array. This will be our sprite positions. And be a number of tiles. I think that's everything I need. Because the image width and height are the same. Okay, so that's good. And then what I want to do is I just want to iterate over my number of tiles. And we're going to change our starting position to be the actual position in the tile positions array. And we want to stop at the position x plus 8 and y plus 8, right? So sprite positions I, and then we're just going to do position y as our starting point, and position y plus 8. And then same thing here, we're going to say position x, and position x plus 8. And the reason we're doing it this way is because we want to just export the one tile at a time, and everything else is okay because the image width and height still are accurate, and we're exporting one tile at a time. All right, so that should be good. And then that is for the meta tile, and this is for this. So we want to do what's the first parameter, sprite position, sorry, tile positions, and then number of tiles, and then that should fix that. And then okay, yeah, that should be good. So let's export that again. I think that will fix the bug. And the sprite rendering, yeah, there it is. So our sprites are now, it looks like rendering properly. Yep, and we've only got the 3 tiles there. So the enemy sprites should show up correctly. Again, obviously our tile data is not right. No, it's not C for the NES. There's C code for the asset tool that I'm working on, and then the actual engine itself for the game is in 6502 assembler. So you can do C for the NES, but it's not quite as efficient as doing an assembly. And awesome, and the explosion actually worked properly, even with that change. Cool. So now we got to figure out how to deal with these sprites properly. That's the sorry, the palettes properly. 11:30. I'm gonna wrap it here because I've been streaming for 2.5 hours. But the next stream here will be dealing with how we handle the palettes, because the palettes are coming in wrong. Obviously, or maybe not obviously, but the sprite palettes, we only get the 4. And the ship is using 2 of the 4, and then the enemies will have the other 2 as they need them. We also have the bullet palette when you fire. But this is creating some problems because we're not managing the palettes properly. And then the other issue is when we import the tiles, we're still getting the problem of things not getting the appropriate positioning, and so by default it was loading the blue tile with position 0 in the palette as the blue color, which is the background, which is getting overwritten by other stuff. We need it to be a non-background transparent color in order for it to work. And the other thing that we're not doing that would be nice to handle properly is for the bumper. Well, for any meta tile, right now our collision data is being manually put in by clicking. I want this to be part of a JSON file too that we're able to use on creation, so that we can just have this be populated as we import the PNG, so I don't have to do this every time. Yeah, 6502 for, well, I mean, part of the challenge on the Atari is that it's so dependent on the kernel for the drawing, and it's super timing based. The NES is a little bit more forgiving in that it's got way more capability. Now the Atari, as I understand it, has some capabilities related to hardware sprites, which is kind of cool. You don't get that on the NES. But the assembly part isn't really that bad. I'm working on a video to kind of go over how the assembly stuff works. I mean, people who have watched this series for a while are probably groaning right now, because I've been saying that for couple of months, but basically the assembly part is just sort of tedious at times. It's really not that big a deal. It's the hard part on the NES is dealing with things like the the attribute table, which we are in this game, and the attribute table is what tells the background tiles what colors they have from the palette, or which palette to use rather from the background palettes. So if you look at the palette viewer, these are the palettes we have loaded for the backgrounds. And so as we are scrolling, you can see there's a little bit of an artifact here as we change the palette colors for the tiles that are scrolling up from the front. And so that's actually the harder part of what we've done, and more so even because of the way that we're handling the scrolling and the palette changes as you scroll. There are a number of streams that I've done, getting around the problems that I had, especially because on the NES you have a row of half tiles, or not half tiles. It's not an evenly divisible number of tiles compared to the horizontal tiles, and so it creates problems with the math involved in updating the palettes, but nothing that can't be figured out, just really frustrating at times. So as far as the assembly stuff goes, like I said, I'm putting together a video, and hopefully it'll be released in the next week. If you check out the YouTube channel, where I've posted all the previous recordings, I've got a couple videos explaining how to get the compiler, the assembler installed for NES development. If you did any Atari stuff, I think they use CC65 too. And then the next video is on number systems, like how hexadecimal works compared to base 10. No, you don't have double buffering per se. What you have is you have this tile map with a scroll register, and so you can see where the lighter part is where the screen actually is. So I can update parts of the screen here that are off screen a little bit and get that scrolling effect. These two parts are different screens, and you can do something like, if you wanted to, actually that raises an interesting point. Right now the scrolling is all here, and we're mirroring horizontally, or wait, it was vertically. I was confused what the two are. It's vertical mirroring. This top one is mirrored with the bottom one. You can also change it so that the left one is mirrored with the right one based on what you're doing. And so the way that I'm doing it, because I was doing a status bar at one point, is it's got one set of tiles here and another set of tiles here, and then it was doing a split partway down the screen where it was drawing this, but I'm not going to end up using that. And as far as sprites go, you have 64 hardware sprites. They're all either 8x8 or 8x16. Not too hard. And about the only thing that's kind of annoying about the sprites is you have to update them every cycle, because if you don't do that, then you end up getting random garbage shown on screen because the memory that holds the sprites doesn't persist after every cycle. And that was, on the real hardware, that was done because it saved money. So Nintendo chose that because it was cheap. Some emulators, depending on how they work, will emulate that properly or not, but you have to update it every cycle. So anyway, yeah, if you also, I did way back in stream number 1, I did a whole hardware architecture overview of the NES, if you want to check that out. That was when I was just getting started. But Anyway, thanks everybody for watching. I'll post the recording as always on YouTube. And if you have any questions, you can find me on Twitter at Clairvis. You can comment on the video and ask questions. Plenty of people have. I'm on Nintendo Age as Zelius, and yeah, thanks for watching, and catch you next time.